We're going to talk about logarithmic functions. One thing that you want to remember, no matter what, is logs are exponents and exponents are logs. Here's something you're familiar with. This is an exponential function. A base raised to an exponent is equal to y. B to the x equals y. Well, that means exactly the same thing as the log base b of y is equal to x. Now I just said logs are exponents. Exponents are logs. Look at here. The x is the exponent. And here is the x. The log is an exponent. What we need to be able to do is go back and forth from the exponential form to the logarithmic form. So 3 to the x equals 729. 6 is the exponent. Logs are exponents. The log base 3 of 729 is equal to 6. One way you can remember this is, Ms. Kozlowski calls it a curly Q rule. And you can do something like this. 3 to the 6 equals 729. She doesn't do the heart. The heart is mine. Isn't it cute? So 3 to the 6 equals 729. It's right here. 5 to the third equals 125. Log base 5 of 125 is equal to 3. And I can do that curly Q thing again. 5 to the third is 125. 5 to the third is 125. 5 to the third is 125. Now here I have 6 to the fourth equals 1,296. Same thing here. Log base 6 of 1,296 equals 4. Using the curly Q thing, 6 to the fourth equals 1296. Here I have 4 to the fifth equals 1,024. Base 4 of 1,024 equals 5. Remember, logs are exponents. So I have log base 4 of 1,024 equals 5. If I'm changing it from this to the exponential form, I can do the curly Q thing. 4 to the fifth equals 1,024. 4 to the fifth equals 1,024. Now, here's a function that you're familiar with. This is the exponential growth function. Remember, the domain is all real numbers, and the range is y is greater than 0, because we have this horizontal asymptote right here at y equals 0. Now, a log function and an exponential function are actually what's called inverses. Inverses means that they are reflections with respect to the line y equals x. I'm trying to move this line. There we go. Get it out of the way. So here's another line. Here's the line y equals x right here. And if I reflect this exponential function over that line, what I end up with is this logarithmic function. Now, a couple things that happen when you do that reflection. I've got the line. You see the asymptote that I had? That was the x-axis. Now the asymptote is a vertical asymptote, and it's the y-axis. It's x equals 0. The domain was all real numbers, and the range was y is greater than 0, because this is as low as I can go with my y's. Now, with the logarithmic function, my domain is x is greater than 0, and my range is all reals. My y's go down forever, they go up forever, but my domain is never going to get past 0. It's never going to touch 0. So look at the domain and the range switched places. Here's the range on the exponential and the domain on the logarithmic function. And if you go on to the next video, this is the next example that you're going to find.